Transforming of graph of a function. How to transform the graph of a function from one place to different place in xy plane. Suppose if I have a function y equals to x square is my function. First I need to draw its graph, and then we'll add some changes in x square, and we'll see where the graph transform in xy plane. So first thing is first, let me draw the graph of x square. To draw its graph, let me put some random values for the x to get the value of y. If I put x equals to -2, -2 to the square is 4. So my y is 4 here. And when I substitute x equals to -1, -1 to the square is +1, which is my y value. By putting x equals to 0, my y will be 0 as well. But when I substitute x equals to 1, my y will be 1 as well, because 1 to the square is 1. Putting x equals to 2, 2 square equals to 4, so my y will be 4 here. Let me transfer this table in xy plane. This is my x-axis, here is my y-axis. The graph will be like here. It's a parabola. It's a perfect parabola, where its ends are located at -2, 4 and +2, 4. What I did here, I have equation x square, y equals to x square is my equation. To draw the graph, I'm gonna put some random values for the x. When I substitute x equals to 0, I got y equals to 0. By putting x equals to -1, -1 to the square is +1, so my y will be 1 because y equals to x square. By putting x equals to -2, -2 to the square is +4, so my y was 4. I got y equals to 4. By putting x equals to 1, 1 to the square is 1. When I substitute x equals to 2, 2 to the square is 4, so my y was 4. Then I transferred this table into graph in xy plane, because I have only x, y values. These are my x values, these are my y values. So I need only x-axis and y-axis. My graph will be in xy plane. By putting x equals to 0, my y was 0. So my first point was here at the origin, where x equals to 0 and y equals to 0. But when I substitute x equals to -1, which is here, my y value was also 1. So my point was here, 1. At this stage I have -1 along x-axis, +1 along y-axis. But when I substitute x equals to -2, my point along y-axis was 4. So 1, 2, 3, 4 at this stage. Similarly, when I put x equals to +1, my y value was also 1. But when I substitute x equals to 2, my y was also 4. At this stage, I got 4 along y-axis and +2 along x-axis. So the left end of the parabola ends up at -2, 4, and the right end is on 2, 4, 2, 4. You can substitute more random values like -3, -4, -5, +2, +3, +4. It's up to you. The more you put random values, the bigger you will get the graph. This is my simple graph up to -2, 4, +2, 4. That was the first thing that I did. Now I will come to the real case, where I want to transform this graph from this place to another place. How to transform the graph? I will do some changes to my original equation, which is x square. Let me do some changes. Let me add 3 to my previous equation. Y equals to x square is my original function, but then I add up 3. So I did some changes to my original function. I need to draw its graph where the graph is located. I will apply the same way. I will put some random values for the x to get the value of y. When I substitute x equals to -2, -2 to the 2 is +4, +4 plus 3 equals to 7. By putting x equals to -1, I got y equals to 4 because -1 to the square is +1, so +1 plus 3 is 4. By putting x equals to 0, I got y equals to 3. When I substitute x equals to 1, I got the value of y equals to 4. By putting x equals to 2, I got the value of y equals to 7. How I did here? I had my original function, which was y equals to x square. I did some changes where I added 3. Therefore, my y values will be different. And then I put some random values. By putting x equals to -2 in this equation, So negative 2 to the square is positive 4. Positive 4 plus 3 equals to 7. By putting x equals to negative 1. Negative 1 to the square is positive 1. Positive 1 plus 3 is 4. By putting x equals to 0. 0 plus 3 is 3. Substituting x equals to 1. 1 to the square is 1. 1 plus 3, which is here, equals to 4. By putting x equals to 2. 2 to the 2 is 4. 4 plus 3 equals to 7. Now I want to transfer this table into xy plane. This is my xy plane. So my new graph will be in this place. This is my new graph at negative 2, 7, positive 2, 7. Let me take my original function. In case of my original function, my y values are 4, 1, 0, 1, 4. When I substituted random values for the x, negative 2, negative 1, 0, 1, 2, by taking my original function x square only. Just ignore plus 3 for instance. Then I add up 3 to get my new y values. These are the values along y-axis. So my graph transformed to this place, which ends at negative 2, 7, positive 2, 7. Suppose for instance I want to ignore plus 3. I'm just talking about my original function, which was y equals to x square. Let for instance ignore positive 3. If I take only y equals to x square, which is my original function, my y values are 4, 1, 0, 1, 4. My graph will be at this place. This is the old place of my graph. If you remember, my graph was at this place previously when I take only y equals to x square. Let's go back to my original function. That was my graph, which starts from origin up to 4 along y-axis and up to negative 2 and positive 2 along x-axis. When I take y equals to x square only, this is my original function. I added up 3, which extends up to negative 2, 4, positive 2, 4. I did some changes to my original function y equals to x square. When I added 3 to all the old y values, I got my new y values up to negative 2, 7 and positive 2, 7. So my old graph transformed to this place. I just transformed my old graph to my new place, which is negative 2, 7, positive 2, 7. Last time it was at origin. Now its vertex is on 3. That's how transforming of graph of a function takes place. When you do some changes to your original function, your graph will also change its place in xy plane. This process is called transforming of graph of a function. Let me do one more change to my original function y equals to x square, which is negative 1. I just subtracted 1 from my original function y equals to x square. I will see that where it is graph transform. Again I will check that where it is graph transform. First thing is first, let me draw its graph here by putting some random values for x to get the value of y. Substituting x equals to negative 2. Negative 2 to the square is positive 4. Positive 4 minus 1 equals to 3. By putting x equals to negative 1, my y value will be 0 because negative 1 to the square is positive 1. Positive 1 minus 1 equals to 0. By putting x equals to 0, my y value will be negative 1 because 0 to the square is 0. 0 minus 1 is minus 1. When I substitute x equals to positive 1, 1 to the square is 1, so 1 minus 1 will be 0. By putting x equals to 2, 2 to the 2 is 4, 4 minus 1 equals to 3. Just substitute some random values. Start from negative 2, negative 2 to the square is 4, 4 minus 1 is 3. These are my y values because y equals to x square minus 1. So whatever value you get at the end, this will be your y value. Similarly, by putting negative 1 for the x square, negative 1 to the square is positive 1. So positive 1 minus 1 is 0. X equals to 0. 0 to the square is 0. 0 minus 1 is minus 1. 1 to the square is 1. 1 minus 1 is 0. 2 to the 2 is 4. 4 minus 1 is 3. Let me transfer this table into a graph in xy plane. This will be my graph. This is my new graph when I subtracted 1 from my original function, which was y equals to x square. It expands up to negative 2, 3, 2, 3, with the vertex at negative 1. This is the exact thing what happened in the previous example when I added up 3. in case of my original function, the y values were 4, 1, 0, 1, 4. When I substituted random values negative 2, negative 1, 0, 1, 2 in case of my original function y equals to x squared. But then when I subtracted negative 1 from my original function, just subtract negative 1 from all the old y values to get my new y values. These are my new y values. Again, let for instance ignore negative 1. Just for time being, ignore the negative 1 if I take my original function y equals to x squared. My old y values are 4, 1, 0, 1, 4. So my old graph was at this place with the coordinate points negative 2, 4, positive 2, 4. If you remember, in case of y equals to x squared, my original graph starts from origin up to 4 along y-axis. That was my original function. But then what happened? When I subtracted negative 1 from my original function x squared, I subtracted negative 1 from all the old y values to get my new y values. These are my new y values. So my graph transformed from the old place to the new place, which is negative 2, 3, 2, 3. This is what happened when I changed my original function. My new graph changes its place from old place to the new place. This is the new graph based on this equation, x squared negative 1. This is called transforming of graph of a function. To transform the graph from old place to the new place when you do some changes to your original equation. By doing changes to your original function, it automatically affects your graph.